Hello, hello everybody. Welcome back to my session after the coffee break. So my name is Andrea, and I've been working for PharmaTech now as an area sales manager for about 10 years. So I've experienced the development of PharmaTechnology from a provider of solution for the dusting and polisher to the company that we are now. So you will see I'm going to present today a completely different technology. So maybe some of you knows PharmaTechnology, which is a Belgian company based in Brussels for the manufacturing again of the deduster, the polisher, and the metal detector. But today, in the last 10 years, we did a big step and we moved into a different type of inspection. So this is a new technology, it's a unique technology. Some part of the machine, okay, the technology was already existing, but is applied to a different type of speed and different type of application. So let's go through the presentation. So that's the agenda of today. We have a quick company overview, the classic PharmaTechnology product range, and we go into the Q-Control. Q-Control is the new division that we set like about 7 years ago, and the product was launched last year. And it includes all the inspection technology. Then we will see on this CUB-X, which is the name of the machine, the technology that we have on board, the critical quality attribute that we can predict with the machine in a non-destructive way, the potential future application and the actual application, and then we have the funny question. So a little bit about PharmaTechnology. PharmaTechnology was founded in the 1993 and is still a family-owned company. We are a small medium company, about 85, 90 people, with a turnover roughly to 30 millions. Our bread and butter remains the deduster and the metal detector, which we do approximately 450 machines per year. But that business gave us the possibility to be renewed as an expert in tablet and capsule processing and develop the quality control division. Our motto is we believe in art of innovation, and our nice identity, corporate culture. I like to read this on a clockwise. So partnership is because we aim to have a real relationship with the customer. You will see the machine that I'm presenting today requires a partnership. It's not a machine that we sell on paper. We need you, we need your expert in PAT, we need your chemometric. So partnership starts as a fundamental. Then the partnership gives us the expertise. So your needs actually helps us to grow. And the growth that we have and the partnership goes into the excellence of our product. Then being top, state-of-the-art with our product is, of course, leading us into the innovation, so the financial possibility to be always ahead. So we work with 65 local agents worldwide. Tema is one of them. And we have 3 different branches in US, in Germany, and in Asia Pacific in Hong Kong. And the headquarters is in Belgium. All the manufacturing and the development is in Belgium. The other one are just 3 sales branches. Field of activities. Where are we? So we are in the process, we are in the quality control, and we are a little bit in the packaging. We will see. So what we can offer? We offer a lot of solution from compression filling to packaging. So just after your nice Korsch double press or metal farm, because we also have R&D machine, or from capsule filler to the packaging, then we can offer. We start with external lubrication. So you have difficult formulation, like they are sticky, you have ejection force issue, then we can help you with external lubrication. The external lubrication from PharmaTechnology are validated to spray less than 0.1% of magnesium stearate, which means that you don't have to re-register your product. So you will see in an increase of quality if you have a sticky problem, but also an increase of productivity. There are customers, there are white paper with customers that could run only at 50,000 tablets per hour because of the stickiness, and with external lubrication, they could go to 90. So in that case, the return of investment is an easy thing to calculate. Then our bread and butter, which means the duster and polishing. So we first spray dust, and then we remove the dust, and the metal detection. So the combined unit is and has been always our bread and butter. We do IPC testing, so the classic, well-known 4-parameter tester with the weight, the thickness, the diameter, and the hardness. And they can be linked together with your table press and for an automatic loop, an automatic regulation of the press. And then it comes the topic of today, which is an online and at-line CQA testing, so critical quality attribute. We do only in Europe visual inspection, so we do not manufacture visual inspection. We just represent into the European market, a Japanese company, but we thought it was matching with the inspection division quality control. And then we have an automatic sorting machine for blistering line. So we sort out broken tablets, twin tablets, and chip tablets, and cap tablets. And that's after that you see on the next slide, after that we have, which is the machine there. So we have the sorting, and the lifting, and we fill the blistering line. Here is an overview of what I have just shown. So double deduster, double tester, which goes up to an OEB4 level, and the same family, but for capsules. So capsule polisher with metal detector and tester. And then we have the external lubrication, the family of the Q control division, which we will talk today, and the packaging, so broken tablet sorting for blistering line. But this is what we do and who we are. So now we pick up one specific product, which is the CUB-X. CU stands for content uniformity, and B for bench, and X stands for a closed platform. So it's a platform, it's a versatile machine with the same size of a small table press, an R&D table press or a small production table press. And it's an innovative and versatile inspection system. So here we do not do visual inspection. We are not checking the cosmetic, even if you will see later, somehow we do the inspection of the geometry of the tablet. But we use the machine to inspect CQA, so critical quality attribute. And it can be used, it's called X again because it's a cross-platform, and can be used either in the R&D to speed up your formulation development, to reduce the cost of your investment in terms of API wasted, and also as an IPC, an intelligent IPC in production, or as a sorting and batch recovery. So we have 3 technology on board. We are going to see 3 types of technology. One is a laser technology, another one is the well-known NIR, but this is a new version of the NIR. And then we have the well-known 4-parameter tester that is manufactured, again, also by us. So we have 3 areas of application, as I said now. Let's summarize all together. So we can use the machine in the R&D for product and process development. It will help you to have a design of experiment and an automatic process development, which means that you will be much faster. You can change parameter in the formulation, and in real time after the compression, imagine you connect a metal farm table press, and in real time after the compression, you see the changes. So you can monitor the API concentration, you can monitor the mass, and derive the content uniformity. And so in real time, you can change your formulation to reach your goal, to reach your target. So you don't have to manufacture, wait the HPLC result, going back, change, wait the HPLC result, and going back again. It's a real-time test. It can be used as an IPC, so you connect directly. Now, I don't think in Turkey you have a continuous manufacturing line, but you can connect directly in a normal batch production your table press, and then from here you can pick up sample, and instead of doing the normal 4 parameter, which is the classic weight and diameter and thickness, you do the API inspection. You do the content uniformity inspection. So an intelligent and a more accurate IPC. Or as an inspection and sorting. So if you want to be sure that your product, your batch has been manufactured according to spec, and in that specific batch you had some problem, then you can use as a batch recovery. Everything anyway is with the goal to have a quality by design. So to help you to have a process under your control. So a robust process that you know exactly and it's under control. So what are the technology on board? So we have the laser scanner. So we'll see later in a video where it's positioned, but it's the first step of the machine. So the laser scanner is checking the thickness of the product, so 100% of the thickness, with a precision of 50 micrometer, and also verify the geometry of the tablet. So if a tablet is broken, or it's half tablet, or it's chipped, then it's rejected as a first stage. It doesn't go to the next step, which is the API inspection, but it's rejected immediately. So as I said, it's not a visual inspection. We will not see if there is some black spot or whatever. For this, you have Mia, which will help you. But if the geometry is not correct, then the laser will reject. So first, measuring the thickness. Why do we measure the thickness? Because later we will predict the porosity. So the thickness is helping us to calculate the volume, tablet by tablet, and we can predict the porosity. So the geometry, and the third, the laser will give the start and the stop to the NIR, because we know the belt speed. So the laser will tell the NIR, okay, you can read from now to now, and the NIR will apply spectra there. And that's the second technology. So the second technology is an NIR spectrometer. But it's not a single point spectrometer, it's an SRS, which is scanning a much higher surface of the tablet. So we go deeper 1 millimeter in the tablet, and we have 9 collimation fiber. So each spectra, we take 9 collimation fiber. This is at high speed. So we talk about 20,000 tablets per hour. So normally an NIR with the reflected technology is 1 tablet per minute. Here we talk about 20,000, and we talk about a much bigger surface. So I notice in bold sentence, because this will be part of the funny question, so keep in mind. So the CUB-X takes a concatenated spectra every 1.6 millisecond. What is a concatenated spectra? Concatenated spectra is 9 spectra. So every 1.6 millisecond, I take 9 spectra of the tablet. Then I have the third technology, which is the classic and well-known IPC tester. Why do I need IPC tester? I need for measuring the mass. So the content uniformity is done by the API fraction prediction and the mass. So I need the mass. And the hardness in a indestructive way. Then optional, especially when we scale up to the different machine, to the bigger machine, which can go up to 120,000 tablets per hour, is used also as a reference method to calibrate the 3D microwave, which is used for the weight, and to calibrate the thickness of the laser. So now that we have been through the different 3 technology, it's nice to see the video so we see where exactly they are located. So you see the machine is more or less a table press, a small table press. So we start with the composition of the machine. So we have the laser scanner, and I'd like to show you here 2 boxes. So the first box is used to reject tablets out of the geometry, out of spec, and out of thickness. So it's also thickness measurement. And the second box is used to reject tablets out of the API value. So we take sample regular interval, and then we start with a centrifugal ball. So a centrifugal ball is positioning the tablet into an under vacuum belt. So it's very important that the tablet is in a fixed position and stable, either for the laser, because as I said, we measure at a precision of 50 micrometer, but especially for the NIR. If it moves during the NIR probe, then it's a problem. That's why the belt is under vacuum. So the first is the laser scanner. So the laser scanner now here is measuring the thickness. The thickness is used to recalculate the volume, because we know the cap volume, we know the edge height, which is calculated with the thickness, and we calculate the volume. And then we can calculate the porosity. Second step, NIR SRS. So here you see I don't have only one fiber. I go down 1 millimeter and I have 9 collimation fibers. So the volume that I scan per tablet, it's much bigger than the single one. Then I have auto specification, they are going out, of course, they are rejected the die speed. Then some customer can say, I'm happy with all the API and laser, and then the conform product just goes straight. And some customer can say, no, I want the content uniformity. Then for the content uniformity, we have the sampling, and then the tablet are measured. Then we track tablet by tablet. We put together the API fraction, we put together the mass, and then we have the content uniformity and the unit dosage. In addition, we measure when you use as a sampling, when you use as an intelligent IPC, we measure the classic parameter. So inside the machine, you have the technology to be used and to regulate the table press in a classic way, or to go further and to have a different type of inspection. So now it comes the reason of the X, so cross-platform. So we said to start from the R&D, so I support product and process development. I give you the possibility of working under the RDT, so the real-time decision, so you can change parameter immediately and avoid wasting of time. Or you can use as intelligent IPC, so connected to a table press, you have your inspection of the critical quality attribute. And then as a sorting, so batch recovery, counterfeited product, any way you want to use the machine to inspect your already manufactured product. So let's go a little bit to the NIR and to understand how it works and how many spectra we can take it. So this is a simple way to describe the process. So you have the belt, you have the tablet going through the belt. The belt is going 1.5 meter per second, so very fast. Then the trigger sensor, so this is given by our friend laser. So the laser scanner is telling the NIR where to start reading and where to start stopping reading. This is to avoid to have some fibers that are out of the tablet, so you are reading nothing. So it can change your mean, and it extremely depends on your tablet shape. So, yeah, we read the tablet, and then we have the scanner of the NIR. So this is a nice tablet, and you see in this tablet I take 3 spectra. So the red fibers are the illumination fiber. So I take 3 spectra, and the yellow one are the receiving fibers, so are 9 collimation fiber. So in such a small tablet, I take out 27 spectra, deep 1 millimeter, so I scan a big volume at 20,000 tablets per hour. It's not one point, it's not a reflecting point, I scan a big volume. And then at the end, I do a mean of those 27 spectra, and I do the prediction of the API. The nice thing is that my fibers, my receiving fibers, can be switched off and on. So this is a patent for PharmaTechnology. We patent the possibility to switch on and off some fiber depending on your tablet geometry to avoid that reading, like in this, you don't want to read in the embossing maybe because you just want to avoid some strange in the mean, strange value in the mean, then you can switch off. So those fibers are all selectable according to really the shape of the tablet. What can we do with our machine? So with the NIR, we do API fraction, and we also do the moisture of the tablet. So, moisture is given by the water, remaining water. Water is reacting to NIR like all the other APIs, so you can calculate the moisture as well. Then with the laser scanner, we do the thickness, and the thickness, as I said, it helps us to calculate the volume for predicting the porosity. And then the 4P is doing diameter, length, and the hardness in a destructive way. So those are the technology on board, the sensor. Then we have, via mathematical model, we have the soft sensor. And then API fraction and mass together, you can calculate at high speed or sample base the API content, so the content uniformity of your tablet. You can calculate the porosity. Porosity is, the mathematical formula for porosity is 1 minus density divided by true density. The true density is given by the customer, it's a parameter that you know. And the rest, which means the density, is calculated by the machine knowing the mass and the weight and the volume of the tablet. And then we are working also, this is coming at the end of the 2025, on the non-destructive hardness, so prediction. So on top of those two, which are already available, and all those one, we will also release the hardness in a non-destructive way. So let's summarize together with a chart what we can do, so, and the speed we can achieve. So if I have an inspection without sampling, I can do the moisture, I can do the API fraction and the laser at 20,000 tablets per hour. If I have sampling, I can go between 2,000 and 20,000, depending on the shape of the tablet, and then I can add all the other parameters, but I go down to 400 tablets per hour. The same if I use the in-process control. And then this value so is given by the scale. So I have to measure the weight. So the weight is measured by a normal scale. That's why I drop from 20,000 to 400 tablets per hour. You will see in the scale up that the other machine doesn't have this limitation because the weight is done by another way. So in the R&D, I can use the machine to have real-time feedback and real-time decision when I change the formulation. I can have a design of experiment which an automatic design of experiment, which is directly linked to an automated process development. And this is I have a nice white paper, which I will show you in a bit, done by Syntegon, where you see the complete line and how can you speed up your process development. So at the end, you have a more robust manufacturing process and a shorter time to mark and a less waste of your API, if sometimes your API can be quite expensive. If we talk about scale-up, then what I presented today is this machine, the CUB-X. So those are the speed you see, up to 20,000 when I do these, or 400 when I want to measure the weight. But I scale up and I go to a CU-120, and the CU-120 is called 120 exactly because it's going up to 120,000 per hour. And this is in any situation, any type of CQA you want to calculate, it will be at 120,000 because we don't have the limitation of the weight, because the weight is done with a resonator, a microwave resonator. And then if you strip out this machine, you reach the other one, which is a double encapsule weighing system, 100%, with also the additional potential of measuring the moisture. So the potential application of today. So we have very interesting. The first one is an inspection. So has been done a white paper with Novartis, which let's see if I'm able to run it. No. Maybe I can run it, yes, very well. So this has been published in a scientific magazine and has been done by Novartis Basel, and is the result of comparing their PAT technology with an high-speed technology. So this is available. If you want, I can forward to you. The second one is a fully automated design of experiment based by Syntegon, which they reproduce the entire line. This is again a paper that you find in a scientific magazine, which I'm going to show you here. So it starts from the granulation to compression and to inspection. And it explains to you the advantages of having an automated process development against having the normal approach. Then, of course, we can measure the moisture of the tablet, the validation for the double-blind clinical trials, and then another thing is very interesting, which has been published by UCB. It's the homogeneity of the tablet. What does it mean? Look, it's very easy. If I go to this, you will understand. So when you have a big block tablets with a breaking line, the machine can tell you exactly if the two parts contain the same API or not. So we can measure at high speed the quantity of API per part. And this is, again, not a marketing thing, but it's a scientific publication. And the last one is the sorting, which I have already introduced. What are the potential future applications that at PharmaTechnology we blocked it? Doesn't go. Yeah. So work in progress between now and 3 years. So at the end of this year, we will add the hardness prediction, non-destructive hardness prediction, and we are working very hard to have in 3 years an evaluation of this integration and this solution. So the utopia, or the dream, is to arrive at 2028 to have a platform which is able to give you the real-time release without having any more the need of HPLC. Funny question. So remember what I said almost at the beginning about the speed. So here I'm asking, how many spectra can the CUB-X acquire in a blink of a human eye? And I brought with me a very nice, one of the best box of Belgian chocolate. So, good luck.